Hi everyone, this is MathsForUni. Today I'll be discussing Step 2 2019, Question 2, Part 3. If you find this content helpful, then please consider liking and subscribing, as well as checking out both of our Udemy courses, of which the links are in the description. The question says, the real function h is defined for all t by h of t all cubed plus h of t is equal to t plus 2. It asks us to evaluate the integral from 0 up to 8 of h of t with respect to t. So we have this relation here that defines h of t. We notice that it is remarkably similar to the relation that defined g in the previous part, which was g of t all cubed plus g of t is equal to t. If we have an input of t minus 2 in here, here, and here, then what do we get? We have h t minus 2 all cubed plus h of t minus 2 is equal to t minus 2 plus 2, which is equal to t. This tells us that h of t minus 2 satisfies the same relation as g of t. Since g and h are defined only by these relations, this tells us that g of t is the same as h of t minus 2, i.e. they are the same function up to a translation. In particular, h of t is g of t plus 2, just by translating in the opposite direction. Hence, if we want to calculate the integral from 0 up to 8 of h of t with respect to t, we can just calculate the integral from 0 up to 8 of g of t plus 2. And the nice thing about that is that we can translate the integration variables and note that this is the same as the integral from 2 up to 10 of g of t dt, either by subtracting 2 from here and adding 2 onto here, or more formally, by using integration by substitution. As a result, all of the work that we did in part 2 of the question can be used to calculate this integral. In particular, we use the same method by splitting this up as the integral from 0 up to 10 of g of t dt minus the integral from 0 up to 2 of g of t dt. We actually calculated this integral here in the previous part of the question. So all we need to do now is calculate this integral here. Again, we use the same method for this. In particular, the integral from 0 up to 10 of g of t dt plus the integral from 0 up to g of 10 of g inverse of y dy is equal to 10 times g of 10 from the first part of the question. So, to calculate this, we need to find g of 10 and then do this integral. G of 10 satisfies the relation g of 10 all cubed plus g of 10 is equal to 10 from the defining relation of g here. We notice that this has a simple solution of g of 10 equals 2 because 2 cubed plus 2 is 8 plus 2, which is 10. So we use the same method as last time by factoring out g of 10 minus 2, giving us the quadratic g of 10 all squared plus 2g of 10 to cancel out the g of 10, or rather g of 10 all squared terms, and then we have a plus 5, and these two brackets multiplied together gives us 0. This is one solution, but how can we be sure that this does not give us other solutions? Well, again, as before, this is a quadratic, and we can look at the discriminant, which is 2 squared minus 4 times 1 times 5, which is 4 minus 20, which is certainly negative. And so this quadratic here has no solutions, and so the only solution is g of 10 equals 2. Therefore, putting this into the integral relation here tells us that the integral from 0 up to 10 of g of t dt that we want to calculate is equal to 10 times g of 10, which is 20, minus the integral here, which is the integral from 0 up to 2 of g inverse of y. In the previous part of this question, we derived an expression for g inverse of y using this definition of g here. In particular, we found that it was equal to y cubed plus y. And so now we can find this just by performing this integral. So we have 20 minus, and then we have a quarter y to the 4 plus a half y squared between 0 and 2. And this gives us 20 minus a quarter times 2 to the 4, which is 16, minus a half times 2 squared, which is 4. And so we have 20 minus 4 minus 2, which is 14. So finally, if we want to calculate the integral from 0 up to 8 of h of t dt, as the question asks of us, then we follow the logic here to get that we need to look at this minus this. Well, we just found that this is, let's have a look, 14, and in part 2 of the question, we found that this here was equal to 5 over 4. And so, therefore, we have the final answer as 51 over 4. Please be sure to check out parts 1 and 2 of our videos on this question if you're unsure of how we derived some of these results with analogy to the previous parts. If you enjoyed this video, then please consider liking and subscribing, as well as checking out both of our Udemy courses, of which the links are in the description. Thanks for watching, and goodbye for now.